Okay. Hi, good afternoon. Thank you very much all for joining. My name is John Turo. I am the Senior Product Manager for AWS Messaging, the simple queuing service and the simple notification service. And by the time we're done today, you're going to learn about how to build elastic, scalable, reliable applications using SQS and SNS. So let's get started. In life, queues are everywhere. If you think about waiting in line for lunch today, it may have been frustrating, right? Because there are more people that can possibly be served in the unit of time that have arrived. And so this long line shows up. And it's so common that we don't notice it unless the line is long and frustrating. But actually, queues solve a really important problem. They are the only best option to solve the problem of more people than capacity. And they ensure that everybody ultimately gets served. Consider the alternative where lots of people rush the desk and nobody gets served, and the guy runs away. So queues solve this very fundamental problem in a really clean and elegant way. In life, notifications are everywhere. If you think about the sign outside a restaurant that says we're open, it's powerful because everybody who wants to know about that can see it. And the restaurant only needs to write it once. And everybody who walks by on the street and doesn't care doesn't have to read it. So in life, we see queues and notifications everywhere solving these basic problems. And it turns out they're really important when you're building large distributed applications as well. So AWS offers the simple queuing service and the simple notification service. And we're going to talk about how they help make your applications more robust. Let's start with SQS. SQS is designed for environments where you have producers and consumers. A producer sending messages one at a time or a group at a time that are going to be consumed by a service, perhaps to create thumbnails or do analysis or store it in a database. And SQS is designed with the insight that eventually your service will become overloaded by too many requests. And if it's not designed to handle that onslaught, it may fail. You may drop some messages. You may fail to do the thing that you're trying to accomplish. And here's how you can solve that problem with a queue. Rather than sending messages directly from the producer to the service that's going to work on it, instead, you can send those messages to the queue. And the queue can accept them at any rate and at any size. And when the service is ready to consume them, it can request the next message or the next group of messages and go to work. And the queue is going to hold on to that message until it's confirmed that the message has been processed by an explicit request to delete the message. So let's talk about it one more time. Instead of sending directly from the producer to the service that consumes it, instead we see a chain of messages where the producer sends, the consumer receives, and then the consumer deletes. And this is powerful because it protects against overloads. And in fact, SQS is designed to be able to support that huge overload scenario, and it's designed that it can't get overloaded itself. Very high throughput. It just works. Our customers put enormously high numbers of messages through a queue. And in fact, if the service on the other side does fall down, does have a backlog, does need to be restarted, the queue can absorb all those messages. And then when the service comes back online, you can suck out the messages from the queue just as fast as you're able to accept them. So a few elements about how we've designed our queues to help build more robust applications with SQS. It's designed to provide high durability, which means you can be sure that the message gets where it's going. It will be delivered. It won't get dropped. It's going to hold those messages until you explicitly delete them. And it'll hold them in a backlog for up to 2 weeks. And you can watch this in progress. You can use Amazon CloudWatch to study things like the depth of the queue. not just for purposes of tracking your billing, but actually for integrating SQS into your larger application. We can talk a bit more about it later, but there's a lot of powerful stuff you can do when you can tell the difference between an empty queue and a very full one. We talked about the 3 major types of requests that SQS supports: send, receive, and delete. And every month, the first 100,000 are free. After that, we charge $1 for every million requests. And we treat batches of up to 10 messages with the same price as we charge for one message. So actually, you can send 10 million messages for the price of 1 million messages if you use batching the right way. So that's SQS. Let's talk about the simple notification service, SNS. SNS is designed for a different environment where you have a producer that is sending messages to a service, but actually may need to get that identical message to multiple services. And it's designed with the insight that eventually the producer will become overwhelmed by too many services subscribing to it. And that's going to overwhelm the primary work it's trying to do of creating that information. What you can use is the simple notification service. We call them topics, an SNS topic that decouples the producer and the services that consume its messages. The producer publishes messages to the SNS topic just once. And SNS is designed to fan out identical copies of that message to each of the services that subscribe to it. And when the services subscribe to an SNS topic, they don't interact at all with the producer. So it doesn't care if you have 1 or 1,000 or many thousands subscribing. This gives SNS flexibility to publish to lots of different protocols. You can send an SNS notification to an HTTP endpoint. You can send it as an email or an SMS message. And you can even subscribe individual SQS queues to an SNS topic, all without any special action from the producer other than producing the information that all these endpoints are going to want to consume. So a bit about how we've designed this. SNS is designed for unlimited fan-out with an unbounded number of subscribers pulling down information from the service, with seamless support for the protocols I described, either an HTTP endpoint, email, SMS, or even publishing to an SQS queue. And you can define, based on the application you're trying to build, how many retries and just how fast those messages can go through. There's built-in CloudWatch support as well with SNS. We break the pricing into 2 pieces. You are charged for pushing individual messages from the producer into the topic. And secondly, there is a different price to deliver those messages to endpoints that varies according to the protocol that you're using. What's pretty cool is that you can push from SNS into an SNS and into an SQS queue for free. So it creates a pretty powerful scenario that we'll talk about where you can push from one topic to multiple queues. So that's SQS and SNS. And they're 2 services, but in lots of ways, they work together to store and retrieve any volume of messages at any throughput or size you'd like to throw at it. And because it's a hosted AWS service, you do it without any operational burden. It just works, and our customers are pretty excited about just how resilient these services have been to the kinds of abuse that they've thrown at it. Here's some of the larger ones that use our service. Folks that you'll meet here, like Netflix and Twilio, Shazam. Amazon, internally, we use SQS and SNS for mission-critical applications like the Amazon.com order pipeline and on the Kindle. We trust a lot in the resilience and the reliability and the scalability of these services. And in fact, we've learned a lot about how SQS and SNS make broader applications more powerful by speaking to some of these customers and lots of others. And it's helpful to think about how SQS and SNS can fit into an application. So what I'd like to do is talk about a hypothetical startup that uses some of the best practices our customers tell us about. This is the imaginary startup Cup a Noodle, which is a very simple but powerful app for ordering food delivery to your house. You can download the Cup a Noodle app and browse menus of local restaurants, order the dish you'd like to get, and after it hits your credit card, that food will arrive at your door. Something that is pretty basic, but important to hungry people. And they make a promise, just like SQS and SNS make a promise, that they're just going to work to both the customers who order the food and the restaurants who trust them with delivering their business. So if you think about the steps you would need to go through to take food orders and deliver them, there are some basic ones. You're going to need to collect credit card numbers. You're going to need to collect orders. And you're going to need to hand them over to the restaurants that will deliver the food. But you may imagine there's lots below the surface, too. You can think about re-engagement. How are we going to get folks who love Cup a Noodle, love ordering food, to come back? How am I going to remember what they've ordered and suggest new orders that they may like? And let's say they order a pizza and want to invite friends over. Maybe I can invite those friends to come to the house and actually try Cup a Noodle themselves the next time they're hungry. So lots of work that happens below the surface, and lots of things that have to happen all at once to get this very simple thing to work every single time. If you're going to build an app like Cup a Noodle, you might do it like this, with a mobile web application interacting with an internet API and 3 backend services. One for batch processing the orders, one for notifying the restaurants, and one for personalizing the experience in terms of the social network and remembering favorite foods, favorite orders, that kind of thing. So let's add another layer of detail, where this mobile web app or a web-based client interacts with actually a pretty sophisticated distributed application. And we're going to spend a couple of minutes talking about how SQS and SNS make this application better. Some of the things Cup a Noodle wants to do have to happen in real time and actually don't interact with any kinds of queues or notifications. For example, if I want to pull down the menu of a particular restaurant in my city, I'm going to send that request from my mobile client through an elastic load balancer and the auto-scaling group on EC2, and it's going to hit the database directly because there's no way to predict just what menu I'm going to want, just which section of the menu I'm going to want. However, even though there are some real-time activities that have to happen on Cup a Noodle, lots of stuff will happen asynchronously, although still very fast. Here's an example of that. If I want to save my favorite meal, perhaps the meal I just ordered, that is going to happen very quickly, but doesn't necessarily need to be ready right away, because if I just ordered the dish, I'm not going to order it again for, you would guess, at least several minutes. So instead, the food order will go through the client, ELB, and auto-scaling group into a queue called favorite meals that's going to hold that. Now, what's cool about this is if I place an order at a peak ordering time and all the compute resources are busy handling the critical workflow of those orders, the favorite meals queue can hold the order until perhaps the middle of the night when those compute resources are less expensive. And then in the middle of the night, that can get processed, and the favorite meal will be ready the next time I'm ready to order. Here's another example. If I'm going to place an order, actually a lot of things have to happen in parallel. I'm going to hit a credit card processing service in real time, perhaps to authorize this credit card. But I'm also going to notify the restaurant that has to deliver the food. And I'm also going to hit my accounting system in my data warehouse that I can use to improve the service and run my business. So when you think about these very basic but very powerful features, perhaps you're asking why this is hard. Well, there are 3 things that we think you want to look for while you're using a queuing and notification service. We think about reliability, where the service is highly available and the messages are designed to be durable, meaning they will get where they're going and they're not going to get dropped. We think about AWS Caliber scalability, where you can throw any level of throughput at the system and any level of backlog. And elasticity in the sense that you don't need to provision that capacity in advance. Finally, we think it should be simple enough that you can build this into your application without becoming experts in queuing theory and instead focusing on the value-added work that you bring to your business and that Cup & Noodle brings to its business. So let's talk about each of these. For Cup & Noodle, availability is really important because downtime means lost customers and lost trust. Now, Werner Vogel's just got done earlier today telling us about we should never assume that errors are uncorrelated, right? Well, if Cup & Noodle's system goes down, it's not likely to be in the middle of the night, but rather it's likely to be at a peak period where they're going to lose lots of orders and lots of trust. So it's really important that they build high availability into their application. Let's see where that plays out. Here are a couple of examples. For example, the credit card billing system, way at the top right, may have to deal with an external service that is not part of the AWS application designed by Cup & Noodle. And that service may be unreliable or may be slow. We don't want to allow hiccups in that service to stop an order in its tracks. And so you can place an SQS queue in front of it. It means you can turn low availability services into high availability services with SQS. And as soon as the credit card billing system comes back up, you can then put the order through. We spoke a little bit earlier about saving favorite meals. Think about crawling that user's social network. It may add value, but the user is going to be frustrated if you hold up their order because, say, Facebook was delayed. So you can then hold the social network crawling instructions until a time when Facebook is available or until a time when your compute resources are less expensive. Here's one more. When we spoke about the pricing for SQS, one thing I didn't add a price for is individual queues, because there is no cost to add a queue. Sending the same number of messages has an identical cost, however many queues you use. And so here, Cup & Noodle has designed their application with one queue in front of each restaurant that they serve. And it's powerful, because if there is a delay in restaurant 2, the orders can still keep flowing through to restaurants 1 and 3 and the rest. So that's availability. Durability is really important for Cup & Noodle too, because their customers and the restaurants trust that they're going to do what they said they would do every time. And so I need to process the order fully. Even worse than dropping the order completely would be dropping the order completely but still charging the customer for it. And actually, it's pretty frustrating for the merchant if I charge the customer for it and I don't deliver the food. So it's really important that the messages going through the queue are durable. And let's think about where it's important to use queuing and notifications to avoid losing messages. Here, we can see that Cup & Noodle has used this SNS topic called orders to fan out each of its messages to the places it's going to have to go. One SNS topic called orders sends an identical copy of the order to the restaurant, as well as the data warehouse, the payments, and the billing systems. And you can ensure that identical copies of that order will reach each of those queues. And because SQS is designed for high durability, you can ensure that the messages will be delivered to the service that is looking for them. Let's talk about scalability, because not every day is the same for Cup & Noodle. They have to serve orders that come in on a Wednesday afternoon, which may be a slow period. But they also have to serve orders during the Super Bowl, which may be a huge spike. At Amazon, we think about Black Friday and Cyber Monday, and those are very different days than a typical day. So we think about how to build scalability into applications. And you can see that using SQS and SNS, we can build scalability into Cup & Noodle. Here, each restaurant may be able to handle a maximum of 10 orders per minute. But because there is a queue in front of the restaurant, the orders will build in a backlog until the restaurant is able to handle them. And if the restaurant then staffs up and is able to handle now 40 orders per minute, they can draw down those orders just as fast as they can handle them, and ultimately try to achieve the rate of the orders that are coming in so they can serve everybody. At the same time as we're thinking about scalability, we also have to think about elasticity. How can I handle these huge backlogs, these huge throughputs, without provisioning for them in advance? Because it would be expensive to provision, for example, for the Super Bowl on a typical Wednesday afternoon. SQS and SNS let you do this. We spoke about how unused queues are free. If you think about all of the queues and the topics and the messages that are flowing through them, while it's not quite free, it's pretty astonishing to think about the fact that this pair of services adds less than 1/100 of a penny to every order that flows through Cup and Noodle. And it means that you can get this elasticity at a pretty cost-effective rate. Finally, we'll talk about simplicity, because Cup and Noodle is great at lots of things. They're great at understanding what are the best restaurants in town, how to get new ones, how to get new customers excited about it, how to enter new cities. What they don't spend a lot of time thinking about is how to process high volumes of messages in high backlogs. And so we worked really hard to ensure that you can use SQS and SNS simply. They are instantly available with no provisioning time, and we're going to do a demo that shows that. You can access them in every region of AWS, 9 globally, and they connect automatically to CloudWatch. So you can watch what's happening, and you can build them into your broader applications. Now, it's difficult to show where on this architectural diagram simplicity is important, because simplicity is important everywhere. Instead, what I'd like to do is show a live demo of how SQS and SNS work together and what they can do. So I'm going to invite Clay McWork from the SQS SNS team to take us through that.
Thanks, John. Is this, can you guys hear me? All right. That's impressive. I got really loud very quickly. So John has done a good job of taking you through how it's important for messaging systems to be reliable and scalable and simple. What I'd like to do is to take a few minutes to using some demo applications that we constructed specifically to kind of show this stuff to you, and the AWS, SQS, and SNS management consoles, take you through how that reliability and simplicity and scalability is achieved. So to do that, so just as a quick overview, this is the demo application that we're going to be using for the next few minutes. The idea is that we can take a look at a queue in the middle. We can analyze the backlog in real time. We can modify the producer behavior on the left, see how the producer rate down here. And the same thing on the right, we can look at the consumer behavior, control the rate that consumers are receiving messages and deleting messages. Now, a little bit more info about this application. Everything you see here today is actually running completely on AWS. We're using all of the publicly available SQS and SNS APIs. This application is actually just a Java web application deployed to Elastic Beanstalk running on an EC2 instance. So to begin, I want to talk about probably the simplest building block, which is the single queue with producers and consumers. In the Cup and Noodle world, that would be something like the credit card billing queue. So this is the SQS management console, and we'll start by creating a new queue. So we'll call it credit card billing, and as soon as that's created, we will then take our queue and begin looking at it. Now, we just created this queue, which means that there's no backlog, so there's 0 messages in it. And we can instantly begin placing messages in the queue. So this is kind of like when Cup of Noodle starts testing their application, right? They're sending a couple of messages every second. And in the center, you can see that there's a backlog growing in the queue. Before I go further, just a quick little aside about the visualization you're seeing here. I'm updating these metrics rather rapidly, every 1 or 2 seconds, and that results in some jitter. You'll see, it goes between 2 and 3, or the backlog is not exactly consistent. When these metrics are pushed to things like CloudWatch, because it's at, it's sampled at a lower rate, you actually end up with a much smoother set of metrics. So imagine then that, we have this queue and backlog is growing, and then Cup of Noodle optimizes their ordering process, and now it's much faster. So now the rate that these producers are in-queuing messages goes up, and they start in-queuing hundreds of messages every second. The queue just absorbs that backlog, and it continues to grow. Then, as you would imagine, as John talked about batch sizes, if for whatever reason they start using batching to in-queue items, as they increase their batch size, the throughput that they're achieving from those same number of producers increases. So now those same 2 producers are producing 1,000 or so messages every second into this SQS queue that we created just a minute ago. So then you say, that's awesome, but then what happens when the Super Bowl hits, right? And all of a sudden you have loads of new producers. Well, as we add new producers, right, the rate that messages are being placed in the SQS queue goes up, as you would expect. Correspondingly, the backlog size grows at a faster rate. So you're thinking, this is great. We have a way to waste EC2 resources and to pay money to SQS to put messages in a queue we don't want. But ideally, right, these are messages that a customer cares about. So then what we want to do is we want to spin up a consumer. So as we spin up the consumer, we can start with 1. How about 4 then, right? As you can see right now, the producers are producing messages at a higher rate than the consumers are, and the backlog continues to grow. The ideal situation, right, is for us to spin up enough consumers that we can quickly drain the backlog, and then the consumers will automatically adjust to match the rate of the producers. So what we'll do is we'll switch over here and we'll spin up 60 or so consumers. Instantly, now we're consuming 20 or so thousand messages every second, and with that, the backlog begins to decrease rather than increase as we saw before. Now, we're going to let this drain for a second. We talked about reliability, right? Every one of these messages that you see is guaranteed durable, right? We guarantee that you will not lose that message. On top of that, right, as far as scalability goes, we've gone from a queue we created minutes ago to, having 1 message or something per second. Now we're sending tens of thousands of messages every second through it. And then thirdly, we talk about the elasticity, right? I didn't have to call up AWS or spin up a bunch of resources and wait for them to get there. You just use it and it's available instantly. So now that we've drained this backlog, the cool thing is that we were consuming at a very high rate. The consumers automatically adjust to where now the queue is in equilibrium. Every message that gets produced is instantly picked up by a consumer. The backlog size stays at 0, messages are processed very quickly, and everything is good. And of course, if at any time your consumers stop for whatever reason, the queue is there to protect you, and the backlog begins to grow. So this is nice, but you might be wondering, what happens when, we built up, let's say this is 500,000 or so messages. What happens when you have a lot of messages? Does SQS handle that well? So what I did was earlier, I started a simulation, right, to build a larger backlog, and I want to switch over to that now. So this is that simulation. So we have a queue that created earlier that now has about 260 million messages in it. We have a producer that is in queuing at a rate of 1,000 per second. Unfortunately, right, when you have a backlog, you can't turn the producers off. That's why you have the backlog. So it's critically important that your queuing system is able to give you the throughput, not just to meet your old throughput, when you were in steady state, but you have to have enough throughput, enough scalability and elasticity, right, that you can quickly catch up to that backlog. So let's see what happens when we turn up our consumers back on. So in this world, we simulate, hey, we finally got our downstream service fixed and everything's better. Instantly, you can see that the backlog, instead of continuing to grow, it begins to drop. At that point, right, we're now reversing the trend. We're no longer growing, and we're starting to reduce the size of the backlog. As we continue to add more and more consumers, what you'll notice is that the rate that you're able to receive messages from the queue continues to increase. Why is that important? Because when you're writing your applications, when you're designing Cup of Noodle, you don't want to think about the scalability of your queuing system, right? The whole point of a queue is to protect you when something else is going wrong. In those situations, you just want it to behave exactly like this. So unfortunately, even at extremely high throughput, right, it's going to take quite a while to drain this, even at 50,000 or 40,000 messages a second. It's going to take a while to drain this 265 million message backlog. So instead of watching that for the rest of the day, what I'd like to do is switch over to the other critical use case that was used by Cup of Noodle and is used by lots of our customers. That use case is integrating SNS and SQS together. By doing so, what it allows you to do is to take a single stream of messages and to distribute that to as many consumers as care about it. Now, to some extent, right, that's kind of this vague theoretical idea, but the experience that you've all probably had is you've been a team that produces something that people care about, the ordering team or the reservation team or something. And some new team spins up, oh, we want to get all that data so we can put it through the data warehouse. And you're like, oh, now I have to go update my configuration and publish it to a new system. SQS and SNS makes it so that that other team doesn't even have to talk to you. They can just go, get your stream of messages, and not have to worry about it. So to demonstrate that, what we'll do is we'll start by creating an SNS topic. We'll use the SNS Management Console, and we'll continue with the orders idea by creating a topic named orders topic. Once we've created that, we'll place it in the simulation, and we'll begin sending, some messages through it. At this point, the topic exists, right? It's instantly available. We created it seconds ago. But the messages actually aren't going anywhere because no one's subscribed, no one's interested. So what we'll do is imagine that there's a restaurant notification team, right, for Cup of Noodle, and they need to get all of the order messages, and they want to put them in their queue so that they can process them as quickly or as slowly as they're able to. So the restaurant notification team creates their queue. And as soon as they do so, right, nothing's in the queue. The reason for that is that the SQS queue needs to be subscribed to the SNS topic. Doing that is super easy. All we have to do is go back to the SQS console, say subscribe queue to SNS topic, click orders topic, and we're subscribed. As soon as we're subscribed, you see the messages that are being published to that topic from a team totally separated, or even a different company separated from this other queuing team. They're now receiving those messages. They didn't have to talk to each other, no communication, easy. The cool thing about this, right, is that you get all of the same benefits you do with a normal SQS queue. I can have no consumers. I can spin my consumers up and consume my backlog as quickly as I like. And once I've consumed that backlog, my consumers automatically adjust to match the rate of my producers. So this is great, but you might be thinking, well, we're only looking at one producer and one consumer here. How is that any different than what we saw earlier with the queue? Well, it's not. Where the real value comes in with SNS topics fanning out to multiple SQS queues is when the data warehouse team wants those same messages, right? And this is where normally, as a developer, you're thinking, I've got to go do a bunch of config changes and code pushes. So we have this new queue. It's empty. We go back. We say, OK, subscribe. And as soon as that's done, the data warehouse is getting all the orders or whatever messages are being published to that topic. And the beautiful thing about this architecture is that the data warehouse team can't affect the producer who's producing the orders, nor can it affect the restaurant notification team. Notice the restaurant notification team is processing messages just like they were earlier, right? Order comes in, they're taking care of it immediately. Now, the data warehouse team, something's wrong with their stuff. They're building this giant backlog. And as soon as they begin to drain their backlog, they can do so, but they have no effect on anybody else, right? So, using these together, right, you can build extremely powerful architectures. These are really just the building blocks, and you can have cascading architectures, what have you. But the key is that using these topics and using them together with queues, right, all of your messages we've seen here are durable. All of this is running on the real system. Everything is instantly available, and it's extremely simple to set up. So with that, I'm going to hand it back over to John, who's going to talk some more about some best practices and some new features in SQS and SNS.
Clay, get the clicker. The clicker. That's it there. Clay, thanks a lot. What's pretty cool about that demo is it's live on the SQS and SNS features that everyone here can use today. And hopefully that inspires you to have a look. As I said, we learn a lot of cool stuff about how to best use. We learn a lot of cool stuff about how to best use SQS and SNS from our customers. And what I'd like to do is share some of those best practices with you. The first is that you can use batching of send, receive, and delete messages to pack 10 messages into one request for the price of one. And you can actually do this for lower fees and for higher throughput and higher efficiency. And what you'll see is you have to accomplish batching each of these request types in different ways. It's probably most straightforward to think about batching a receive request, because if there are at least 10 messages, you can draw down the next 10. And similarly, if there are at least 10 messages in your queue, you can delete at least 10. When you think about batching your send messages, it's a little bit tricky because they may come in one at a time. Your orders to Cup a Noodle may come in one at a time. And so it can be difficult to think about how can I then aggregate those into a batch. And some of our customers have actually built special logic that holds onto those messages and automatically groups them for easier batching. We'll talk about a better way to accomplish that in just a minute. You can also use SQS queues as part of a broader application that scales automatically to efficiently draw down the queue when it's large, but conserve resources and expense when the queue is not large. And you can use the Amazon AWS CloudWatch metric of queue depth that tells you how many messages are waiting as a trigger for your auto-scaling group, so that when I have 50 messages in the queue, for example, I may add more consumers and draw it back down to a steady state. Batching and auto-scaling. Now, it's been a really exciting last couple of months on the messaging team, and we have some new features that we'd like to tell you about that can help achieve those best practices more easily. Long polling was released about a month ago and solves a very important problem. When you send a receive request to your queue, if there are no messages, you'll get back an empty receive request, which is basically wasted, right? You've asked for something and you've gotten nothing. And nonetheless, our customers tell us they can poll the queue at a very high rate because if there is a message that they want to receive, they want to get it just as fast as they can. If you think about how many of these type of requests you would do in, say, a 20-second period, you could think about the fact that you'd be polling about 20 times per second to get continuous coverage under the old way of doing things. Long polling fixes that by, when it encounters an empty queue, persisting up to 20 seconds, and then sending through the message just as fast as it arrives. In the example I gave, where it may be the middle of the night and there may be only one message in a 20-second period, but but you'd like to know just as fast as you can, long polling would actually be a 400x cost saving over using short polling. Now, a lot of situations are going to be less extreme than that because you'll have a higher rate of messages. But still, our customers who have used long polling already tell us it is extremely effective for them. What's cool is it's also extremely easy to use. There are two ways to implement long polling. The first is a way that actually requires no changes to your application at all. You can tag an individual queue with long polling support, and it will just work. You'll want to check your application to make sure it won't time out in 20 seconds, but if it doesn't, there's no other work required. At the same time, you can get greater flexibility by adding long polling as an attribute to individual requests. You can have more flexibility in the way you use long polling versus short polling. Our customers outside Amazon and also the services within Amazon that rely on SQS tell us that there's almost no reason to use short polling anymore. This is just better. I'm pretty excited about it, and it's been released just in the past few weeks. The second feature that I'd like to talk about is the SQS Rich Client, which is a bit of client code that sits locally on your server or EC2 instance, and it ties together your applications more closely with SQS. This has two main benefits. The first is send buffering, which solves the problem of how can we efficiently and effectively batch our send requests into SQS. When you use the rich client and when you enable send buffering, it holds outgoing send requests for a user-defined, customizable period of time. And it watches to see if other send requests are going out. If they are, it automatically batches them and sends them as a batch to SQS. What's cool about this is it doesn't require you to make any other changes to your application. Your application can continue to send requests as normal, and the rich client will catch them and batch them. That's send buffering. The rich client also supports receive request prefetching, which can cut down on the perceived latency that your application will find waiting for the next batch of messages after it's completed the previous one. With prefetching, once your application is finished with a batch, there will be another one waiting. And again, this doesn't require any changes to your core application if you use the SQS Rich Client. This has also been released in the past couple of weeks, initially for the Java SDK, and we have other SDKs coming up in the coming weeks. So that is long polling and the rich client. And today, we've spoken about two services which work separately, but in some cases work better together. The simple queuing service, SQS, for queuing and pull, and the simple notification service, SNS, for push and fan out. And as a quick review, when you're thinking about how to solve the problems of long queues and high fan out, you should look for solutions that have high reliability, high scalability, and which are simple to implement. Now, we've got a couple of minutes to answer any questions you have. At the same time, feel free to check out our developer documentation online for SQS and SNS. Thanks very much. Yes?